Okay, let's talk about arrays now. But just remember, matrices are two-dimensional, and like vectors can contain only one data type. Okay? Then they say when there are more than two dimensions, we call it an array. When there are multiple modes of data, you'll use the data frame. Okay, we talked about that already. We're going to talk about it again later. Okay, arrays are similar to matrices but can have more than two dimensions. They're created with an array function of the following form. So it looks familiar. We have the array function just like we had the matrix function. We have a vector just like before. We have dimensions, which, because an array can be three-dimensional like we saw, but it actually can be even higher dimensional than that. Of course, then you can't visualize it. But just to quickly explain that so that it doesn't sound weird or confusing, let me go back to here and say, remember that because it sounds like higher dimension, sounds like something mystical or something, but it's not like that. So all it means is, when did we have that? All it means is this. So if we have a matrix that's two-dimensional, right? So that means how do we refer to an element in that matrix? We saw how to do that here. This would mean that would refer to the first row and the fourth column. That would refer to this element. So if you have three dimensions, we'd say how do you refer to an element in that? So you'd have like 1, 4, 2 or something. 1, 4, 2. And that would refer to the first row, the fourth column, and the second layer back. Okay, so like that would 2 layers back. But then if you have more dimensions than that, all it means is like you'd have more than 3 elements in here. So here we have, when there are 2 elements, we have 1 comma. If there were 3 elements, like 1, 4, 2, 1, 4, 2, we have 2 columns. If there were 4 elements, we would have 3 commas. And let me just write it down. May as well write it down. So we might have something like this. Now I don't know, maybe this doesn't make it that much clearer, but this would mean if it was just these two, it would be the first row, fourth column. If it was these 3, it would be first, fourth, second. If it was this, it would be this. Maybe that doesn't make it that much clearer, but it's not anything mystical or strange. It's just a way of referring to basically more, well, anyway, let's just leave it at that. Okay, so let's just try it. Let's see an example, maybe. Okay, so here, what are we doing? We've created an array. This is obviously a vector. Has these are probably headings, right? And okay, so and then we have another vector here. And these are probably headings also. Remember, I mean headings, I mean like column names and so on. And here's another one, probably headings again. Okay, so here, we're creating an array. This doesn't say matrix, it says array. We're using a vector, 1 through 24. And here, this is going to tell us that there are 2 rows, 3 columns. So this is the number of rows, this is the number of columns, so we need to say that. Just like before, remember we had n rows, n columns, but we could specify the number of rows and the number of columns. Well, here we do it this way, and now we can say there's 2 rows, 3 columns. Instead of n rows equals 2 and n columns equals 3, we just do this. And then there are 4 so-called layers. Now in this case we're talking about something like this. here. So there's 4 layers back. Okay. I just hope you don't get confused by if we have 4 dimensions or 5 dimensions and think that's somehow special. It's not. Okay, anyway, so here we only have 3 dimensions, so it seems it's possible to think about it visually. And then remember, we can give names to the headers, like the, so we're doing that here, here, and here. Okay? And that's all being assigned to here. So now Z is the array. Now if we print it out, if we ask to see what it looks like, we're going to get this. Okay, so this is not too hard to understand, because what it's going to tell us about is, in this case, since it's only 3 dimensions, we can visualize it. What it's going to tell us is, what's this one look like? What are the elements in this block here? Then the second layer back, what are the elements in that? And then the third layer back, what are the elements in that? And so on. So that's not too hard because we can visualize 3. So here, the first layer looks like this, or sorry, looks like this. The second layer looks like this, and the third layer looks like this. And the names of the, let's see, the names of, okay, look at this, A1, A2, B1, B2, B2, B3. So what that means is here, so that, what was it? I think this was A1, A2, A3, I forget. And then this was B1, B2, B3 maybe, or maybe it was vice versa. So like the names of the columns are B1, B2, B3, names of the rows are A1, A2, A3, and the names of this way are C1, C2, C3. So, and remember how we referred to, let's go back to this. Remember how we referred to the second column? We did nothing here, so all rows, and then the second column, right? So how do we refer to the first layer? So we don't specify the first element, and we don't specify the second element, but we do specify the layer element. So that's what they've done here. Okay, so we don't specify the first element, nothing there. We don't specify the second element, nothing there, but we do specify that it's here, that it's the first layer. That means this is the entire first layer. So here we don't specify the first element, we don't specify the second, but we do specify that it's the third layer, so this is the entire third layer. So it's all the elements of the rows and columns, but only for the second layer. And same thing here, all the elements for the first and second, all the elements for the rows and columns, but only the third layer. Now, okay, this one actually has 4 layers. Okay, so it's not exactly that picture that I showed you because it has 4 layers instead of 3. You can see arrays are a natural extension of matrices. They can be useful in programming new statistical methods. Like matrices, they must be a single mode. So remember that if it's going to have numbers in it, like these are numbers, then these are numbers. So everything has to be a number then. These are numbers. Whoops, no, I lost that. Everything has to be a number. Okay? Okay. So they have to be a single data type, or as they say in R, a single mode. I think mode is slightly less specific than data type, because if you recall, if you've done programming, you recall that we have data types like integers and doubles and so on. So integers are not fractions, but mode doesn't get that specific. It just says numeric or character or something like that, so it's not quite as specific as data type. Okay, identifying, so but anyway, you could have here, even though we can't visualize it, you still could have more than 3 dimensions. So then you'd have more than just 3 numbers here. and you could do that. Okay. I'm not quite sure. I haven't tried it, but I don't know how it would, when you print Z, I'm not quite sure how it would show it. Okay, next we'll do data frames, so we'll come back to that in a minute.